Dear students, today we will be further discussing about the iterative structure. We have discussed about loops and it's have given different examples of the loops. So today we will be discussing one distinction between the loop. One is called pre-test loop and one is called post-test loop. So let's have an example of it using a flowchart. So here you can see that on the left side here we have the test condition at the first, and if the condition is true then the loop enters into the body and then it goes back to the condition, and if the condition is false then the loop is terminated over here. However, in different languages there is another kind of loop, which is we first enters into the body of the loop and then we check the condition, and if the condition is true we are going to end this loop, and if the condition is false then this loop is going to be executed again. And in different languages this is a little bit different. For example, on the true condition it will again go to the body, and on false condition it will end. So in this module we are talking about such a loop which checks the conditions after the execution of the body, and such a loop basically does not exist in the Python which we are using already for pseudocode development in this course. So now if there is a structure that is not available in a language which we are following to develop the pseudocodes, then we can get similar concepts from other languages and we can take it from some other language as a borrowing from other programming language. So that kind of basically structure which we are trying to discussing over here is the repeat until structure. And this is saying that repeat take a coin from your pocket until there are no coins in your pocket. So this means we want to empty the pocket, and however first we are not checking the condition. So first of all we are taking first coin from the pocket and we are assuming in this loop that there is at least one coin available in the pocket. So this means that such a loop can be used at a place where we know that it should execute at least once time and then it should check the condition. For example, there is another very well-known example which I can quote here, that for example if you want to read some variable from the user and user give you input, as we did in the previous module, the input of the factorial, and that input, if you want to make a statement that input cannot go beyond the value of 10, so it should remain within 1 and 10, but it should ask the value from the user. So we will put the body of the loop before the condition checks. So we will say, okay, enter your value, and the value will be entered by the user, and then we will check the condition whether that entered value is within the limits which we actually wanted to acquire from the user, or it has gone beyond the limit. So we will put a condition that while n is less than or n is greater than 10, in that condition it should again ask the user to enter the value. So similar kind of scenarios in which once the loop should be executed and then should check the condition can be written using such kind of structure, which is repeat until structure, and this is called post-test loop, that is checking the condition after execution of the body of the loop. Then there is another very important structure in the context of loop, that is called for loop, and the syntax of for loop is written over here. So this also do the same thing as the while loop was doing, and we are not at the moment going to distinguish between what is the difference between while and for loop in this course. You will be learning computer programming in next courses, and then you will further focus that what is the main differences of and in which conditions and in which scenarios you should use which kind of loop. But to represent as a pseudocode, you can write for loop in this way. For example, you have written sum is assigned 0, and for number in list, so we want to execute or we want to go through the list, and in the list we are saying that all of the numbers should be summed up. So I have written this code over here because similar problem we have solved in one of the previous module where we sum up all of the numbers available in the list. So let's have another example. For example, if there is a list containing students who are pass or fail. So let's say there are number of students in the list and there are their marks. For example, first got 20 marks, the next got 58, next got 90, 87, 30, 12 and 98. And if you want to calculate that how many students are pass from this list, you can write the for loop as follows. Count is assigned by 0, which means this is a variable and this contains the value of 0 at the moment. And then you are saying for number in list. So for all of the numbers in list, if number is greater than equal to 50, what we want to do in this situation? We want to add one value to the counter. Count is assigned count plus 1. So this means initially the count has the value of 0 in the RAM, and as soon as it follows, the loop follows, when it reaches over this second value which is 58, the count is changed to 1, and then when it reached to 90, the count is changed to 2. At 87, the count is changed to 3, and then 30 there is no change, then 12 there is no change, then 98 there is a change. So this count contains the value of 4. So the count will be 4, which means we have counted the number of pass students from the list using the for structure. So if we summarize today's module, we have learned about flowchart, the diagram which we have shown, which had the condition and the body, and we have also learned about pseudocode, and we have learned about for loop, that how we can write the for loop to represent the pseudocode.